Welcome to the Explainer. You know that click, the one you make 1,000 times a day? It's not just a click, it's the start of an incredible high-speed race inside your computer. It feels totally instant, right? But it's actually this super precise journey. So today, we're going to follow that path, all the way from your finger, deep into the computer's brain, and then right back to your screen.
I mean, really think about it for a second. What actually happens in those tiny fractions of a second after you tap a key or click your mouse? You click an icon, and boom, a whole program just pops up. It really does feel like magic, but guess what? It's not. It's a super fast, totally predictable process. And that's exactly what we're going to break down, step by step.
All right, so this might look a little complicated at first glance, but don't worry. The basic idea is actually super simple. Look, everything your computer does, everything, just boils down to these four things. You give it an input. It has to process that input. To do that, it needs to grab stuff from storage, and then finally, it gives you an output. That's it. Input, process, storage, output. That's our roadmap for this whole explainer.
Okay, to make all this technical stuff really stick, let's use an analogy that's a bit more, well, delicious. Let's think of your computer like a super high-tech kitchen. You're the customer, the diner. And your click? That's you placing your order. It could be a simple click, a key press, whatever. It's your order. And of course, every great kitchen has to have a master chef, right?
So who is this master chef in our digital kitchen? Well, it's probably the most famous part of any computer, the CPU, the central processing unit. This little guy is the absolute heart and brain of the whole show. So here's our chef, seen in two different ways. On the left, that's the actual physical thing, the CPU chip. It's this amazing little square of silicon. Then on the right, you've got the blueprint, kind of like an architect's drawing of the computer. And look where the CPU sits, smack dab in the middle. See it there? It is the central hub for everything. It's directing all the traffic. It really is the star of the show. So yeah, the CPU is the doer. It's the one that gets things done. Back in our kitchen analogy, it's not just reading the recipe. No way. It's the one with the knife out, actually chopping the onions, the one stirring the pot on the stove. It's the component that takes your order and turns it into a real, tangible action.
But here's a cool thing. Our chef isn't just one person. It's more like two specialists working in perfect sync. First, you've got the control unit, the CU. Think of this as the head chef, the brain of the kitchen. It's reading the orders as they come in and telling everyone else what to do next. Then you've got the arithmetic logic unit, the ALU. Now this is the sous chef, the hands of the operation. It's doing all the heavy lifting, all the math, all the comparisons, all the logical work.
All right, so we've met our chef, the CPU, with its brain and its hands. But how does it actually know what to do? I mean, how does it take an order and turn it into a finished dish? Well, it all comes down to this really fundamental core recipe. A simple three-step dance it does over and over. And here it is. It's called the Fetch-Decode-Execute Cycle. I know it sounds a little technical, but trust me, this is the absolute fundamental heartbeat of any computer. Don't get bogged down in all the little labels on this diagram. Just look at the arrows. See that? It's a constant loop, from the CPU to memory and back again, over and over. That loop is everything. Let's bring this back to our kitchen. The workflow is actually pretty straightforward. Step 1, the chef has to fetch the next line from the recipe book. Step 2, they have to decode it. Figure out what mince finely or sauté actually means in practice. And step 3, they execute it. They do the thing. They chop the vegetable. They stir the pot. Fetch, decode, execute. And they do this millions, even billions of times a second. It's mind-boggling. And the speed is, well, it's just staggering. We're not talking about this happening once or twice. As our source material points out, this whole cycle happens in mere milliseconds. That means it's running millions, sometimes billions of times every single second. That incredible speed is the secret sauce. It's how your computer seems to respond the very instant you touch it.
Okay, so our chef has the recipe, and they know the three-step process. But what about the ingredients? Where does it get all the stuff it needs to cook with? Well, any good chef needs two things:
a workspace right in front of them for what they're doing now, and a bigger pantry for all their supplies, right?
And that is the perfect way to think about the difference between RAM and storage. Think of RAM, that's random access memory, as the chef's countertop. It's right there, it's super fast, and it's holding all the ingredients and tools the chef is using right this second. The catch? When you turn the power off, whoosh, the countertop gets completely wiped clean. It's volatile. Now, storage, that's your hard drive or your SSD, that's the pantry. It's a little slower to get things from the pantry, sure, but it holds everything long term. All your programs, all your photos, they're safe in the pantry even when the power's off. It's non-volatile.
And here's what these two things actually look like in the real world. On the left, those long green sticks, that's your RAM. That's the countertop, ready for action. And on the right, that black rectangle, that's a solid-state drive, or SSD. That's our pantry. So you can just imagine our chef, the CPU, constantly zipping back and forth, grabbing ingredients from its super-fast RAM countertop and only heading over to the pantry, the SSD, when it needs to put something away for later or grab a whole new recipe book. Okay, we've got all the pieces on the board now. We've got our chef, the CPU, we've got the recipe, that Fetch-Decode-Execute Cycle, and we've got the kitchen with its countertop and pantry. So let's put it all together. Let's trace the entire journey, from your order to the final dish arriving at your table.
And it all starts with you. It has to. Your click, your key press, your tap on the screen. That's the order ticket printing out in the kitchen. Every single time you use an input device, you are the one who kicks off that whole incredible fetch-decode-execute cycle.
So after all that fetching, decoding, and executing, after all that high-speed processing, the computer has to give the result back to you, right? And that's where output devices come in. Your monitor showing you the result, your speakers playing a sound, a printer making a hard copy. That's the waiter, proudly bringing that perfectly cooked dish right to your table.
And boom, here it is. This is the whole shebang. This incredible diagram puts every single piece together. So let's trace it one last time, from start to finish. Your input is the order. That order goes straight to the CPU, our master chef. The chef gets to work, using its fast RAM countertop and its big storage pantry, running that fetch-decode-execute cycle over and over and over again, until the job is done. And finally, it sends the finished product to an output device, serving it right back to you. That right there is the entire journey of a single, simple click.
So from now on, every time you click or tap or type something, you'll know what's really going on. It's not magic. It's this incredible, lightning-fast ballet happening under the hood. It's a recipe. And now that you know that recipe, the only question left to ask is, what will you create?